Good afternoon. Thank you for joining us here at Milipol. My name is Dan Kazita. I'll be hosting the next 30 minutes discussion on CBRN detection technology with an emphasis on screening for chemical, biological, radiological, nuclear hazards, explosives, and illegal drugs. The original emphasis is on checkpoints, but that really covers actually a lot of different situations. It covers things as not just the traditional aviation security mission, but also the border and customs mission, major events, protection of major events like major sporting events, and also critical infrastructure protection. With me today, I have 4 experts here from industry in France. I'd like each of them to introduce themselves. We'll start out with our colleague from Smiths Detection.
My name is Jean-Marie Julien. I work for Smiths Detection, and the company is involved for CBRN protection in detection.
Okay.
My name is Laurent Pasco. I'm a mass spectrometrist from HCFDC Technologies, and we are a provider of all type of analytical instruments.
I am Eric Damiens. I am a marketing and sales director of a company called ProEngine, specialized in chemical and biological alarm detection systems.
My name is Laurent Almedo. I'm working at CEA, which is Atomic Energy Commission, a French public body engaged in research and technology and development of new CBRN technologies.
All right. Well, thank you. First thing I want to talk about is technology. We have, this is an area in which technology is constantly evolving. I've been working in CBRN for 22 years, and very much now the tools and technology and science that we have now is a far, far distant cry from what we had when I started in 1991. So I really wanted to ask the 4 of you, where is technology going? I've seen a lot of movement in the last few years, a lot of interesting things happening, but this is really your chance to talk about where you see technology going, whether it is in chemical or radiological or explosive or drug detection. So if any of you would like to start on that.
If we are talking about chemical detection, and especially CBRN chemical detection, there is a lot of technologies that have been available, but mainly when you go on the field, there is 2 technologies that have been available since 30 years, I would say, which are IMS, ion mobility spectroscopy, and flame spectrometry. There's been a lot of projects, especially coming from US, I think, by different institutes, with very promising technologies. But if you are talking about alarm detection, today on the field, we still find, I think, 95%, even 99% of the market is covered by IMS and or flame spectrometry. We heard some years ago new technologies that were called SAW, surface acoustic waves detection, but it was very promising in laboratories, but when you go on the field, when you have to work with the very difficult weather conditions,
Yes.
humidity, temperature, and so on, still only IMS and flame spectrometry that we can call FPD can be really found on the field for military, for police, for customs organizations also. That's mainly, if you are talking about alarm detection, of course there is a lot of things about identification,
Yes.
which is different. But
Yes,
if you are talking about alarm systems, that's the 2 main ones.
Well, that's a very good point. You mentioned that, for example, one of the key technologies for definitive identification can be considered to be mass spectrometry. We have from Agilent here an expert on that. Where do you see mass spectrometry now and in the future as a security technology?
Since 2 or 3 years, there is a big change in the market as we see that customer needs more and more complex method for more and more analytes in the same time and with less and less time. So we are going with 2 very high-level technologies, and we really see a difference in the market. Single quads going to triple quad going to high resolution, and the market is clearly going to very high level of instrumentation because they are very, very complex analyzed to make.
Okay. How about the perspective from Smiths Detection? I can speak from experience that Smiths Detection really represents a broad range of technologies, from X-ray based systems all the way now into its new Guardian mass spectrometer system with strong offerings in things like FTIR and Raman technology, as well as being a traditional player in the IMS technology. What's your perspective?
Concerning Smiths Detection, the technology we control is IMS, Raman, and spectrometry of of mass, sorry, and our direction is to not manage the technology, but to manage the behavior between, the interaction between the guys in charge of the detection of the control and the machine. Our main development is for software, for example, to be in front of the risk, because the threat is coming to the critical infrastructure, the threat is coming to the airport, and we have to organize more control before the threat is coming in the right place to do a lot of damages.
Okay.
So we developed some software to help or to guide the operators, not chemical, but only operators, to make sure that they have a good samples and good analysis, and to transfer the right information to the chemical people, not in front of the threats.
And finally, our colleague from the radiological industry here. Radiological screening is a very large component of the ports and borders market, for example. Where do you see the developments going in radiation? In particular, I'm curious about new detection materials, because for many years sodium iodide and cesium iodide and plastic scintillators have been very much the basis, the workhorse, if you will, of radiation detection. But that's old technology. Where are we going in radiation detection? Specifically, where is your organization going?
So CEI is effectively involved in radionuclide detection and identification, and in that field we have developed several innovative detection and identification technologies. I have in mind a gamma camera which permits to make snapshot by combining visible imagery and gamma imagery in order to give to first responder the possibility to have picture of the instantaneous picture of the scene, and answering to your question on new materials, effectively we are working on the new scintillation materials, especially in new classes of plastic scintillators, combining, for example, IZ products like lead or bismuth in order to make specific polymers which have the capability to give a high level of sensitivity, and also to address the question of gamma spectrometry with plastic materials. And in addition, we are also working in the biofield, in the chem field, and I will give another example. In the biofield, responding to the need to give to first responders tools in order, for example, to have detection in the field, reliable detection in the field, and also biocollection. And this example is a individual biocollector or biodosimeter, which permits to collect all the particles going from the virus to the bacteria, so going from nanometers to micrometers. And I'm very proud to announce that we have transferred this technology to a French company, Bertin Technology, which is a very specialized and a famous company in the field of biocollection.
Okay. Well, while we're still talking about the issue of technology, one of the things I want to bring up is a problem that spans all of the detection technologies and disciplines that we represent here at the table. Specifically, the false alarm problem. Particularly when we talk about screening of people and screening of goods. We do not want false negatives, because that means bad things or illegal things get past security measures, and that's not good. We don't want false positives, particularly in large-scale screening operations where false positives mean delays. They mean possibly even shutting down airport terminals or shutting down commercial ports of entry or evacuating buildings. Across the various technical disciplines where you work, what's being done to reduce false negatives while reducing false positives? I know that's a very hard balance to make, because if you increase the sensitivity of something, you increase the potential of false alarms, false positives. If you if you broaden the selectivity, for example, that has penalties in engineering design. So I'd be curious to see what your perspective is on false alarm reduction as a general technical discipline.
Another difficulty I would like to point out is that depending on the user, what one user would consider as a false alarm is considered as a real alarm by another type of user who has another mission. So it's very difficult, of course, to pretend for anyone that we don't have any false alarms. Of course, there has been a kind of war for sensitivity in the 80s and 90s to have all the equipment more sensitive, but I think this war is over now because everybody has about the same type of sensitivity. And of course, reducing the false alarm is really the main trend for the near future. A false alarm depends on the user, as I said. It depends also on the type of technology. False alarms are not the same depending on the technology. They are very false negative or false positives. Today, what we can feel from the users that they don't like false positive. False positive is really a big problem, especially if you are talking about checkpoints. We are talking about checkpoints, you are talking about a freight of people or rate of vehicle going through that checkpoint. And if you have alarms all the time, you end up blocking the checkpoint. So that's one of the very big issue, which is not very easy to solve because it's a problem very difficult to define. And the definition of false alarm will change from one user to another user.
To help that, there's two solutions. First of all, the way all the competitors are working is on software, because we need to help the user, the first user of a system, to decide if it's a positive, a negative, and where you are always a gray zone. So we must reduce this gray zone. Yes. And the competitors are making a lot of efforts on the software to help the customer to take his decision with less and less incertitude and less and less human decision to take. So that's one of the main issue for that. Okay. And there's another issue on that for the false positive is that the instruments are not so sensitive that what is a blank? Sometimes you don't have any real blank. When you go to another instrument which is more sensitive, yes, you will find positive everywhere. Yes. Is it because you have a pollution? Is it because your sample preparation? Or is it because the blank is polluted?
Well,
and that's a real issue.
That is a real issue. That becomes an issue, of course, in radiation detection, where we are surrounded every day by natural background radiation, which will vary from, I know in a city or industrial environment, the background radiation will vary literally from 1 meter to the next. No. So obviously the radiation detection industry has had to confront the false positive issue.
Sure, so I think that an element of strategy is in the fact to make detection and to make identification and crossing both. As an example, we have developed technologies which permit to make real-time identification and with effectively specific data treatment, specific algorithm, we can make automatic rejection of all the naturally occurring radioactive materials and get a very specific spectrum dedicated to an alert. And in addition, in order to reduce the false alarm rate, we have developed specific concept of operation by using reachback expertise in the field of radar nuke detection, and it permits to have a separation between the work of the security officer in the field, for example, and the work of the expert, which give effectively, if necessary and in specific case, a right analysis of the signal. And I am right with the fact that you were saying that data fusion is very important, and in the field of explosive detection, we have developed multi-sensor technologies based on the crossing of different technologies and the use of data fusion algorithms, which permits also to reduce the false alarm rate.
Well, how about Smiths? Your equipment is in practically every single airport I've ever seen. Yeah. So that means that really, from both a technical perspective and from a commercial perspective, you don't want to see false alarms because that means people won't buy your equipment, and that's false alarms are
exactly the limit for the product and the end users. We have, for example, private companies that ensure security for example, airports, and we know in this case, a lot of people they are not the same during the day. A lot of people change the job and move, and the main problem is to train at the same level all the guys or the people that are in charge of security. In a position for administration, army, civilian securities, fire brigades, people are specialists. They know with their own experience how to manage the risk in general, how to manage the technology or the device for the control and the detection. And the same product could be a lot of false alarm in private fields, for example, and small level of false alarms in the real fields with fire brigades, for another example. So our topic is to be sure we train correctly the guys in charge of security, but we don't manage at the end which happen with the material, because we don't stay in front of the material or in front of the guys in charge of security. It's not really the same with administration. They cover on the control, the training for the guys. Concerning the radiation, the level of false alarm, it's clearly not important for us, because the technology is mainly controlled by the industry, and we know how to produce a right device with the right technology to be used by the fields. The main thing, at the limit of the cover for the risk, sometimes we met different material or threats. So the main point to avoid false alarm is to bring maybe two devices or two technologies in front of the risks. The problem is just training on the cost for the people they are buying or they are producing the systems. So for Smith, we developed some different concepts, small units with small end using, like end using, for example, not big systems. And we prefer to have several systems to control the same risk or the same way for the risk, instead of a big material to control everything everywhere. It's our point of view and our direction.
Right. Well, that's very good. We've actually kind of shifted already into the second area which I wish to discuss, which is the user perspective. We've already addressed that quite closely here, because, as we all know, the user doesn't like false alarms any more than the manager does. I think one of the interesting things raised by our colleague from Smith's Detection here is the user training. Where do we see our devices going as far as the training requirements? As technology gets more complex, there's obviously the risk of training requirements becoming harder rather than easier. How are we addressing that from a user perspective?
I think users want something, even if the technology is very complex, users want something very simple to use, and that doesn't make false alarms, that is light, and because if we are outside of the military market, where people have a lot of training and are using the equipment very often, when you are talking about borders and sometimes police, they don't really know what CBRN means. They just need something that tells them there is something and there is nothing. Yeah. And with, of course, the lowest level possible of false alarms. So the users, they want something, I mean, like any user of any instrument, they want something simple, easy to maintain, easy to and easy to use. And so that was the challenge when you are talking about very complex technologies.
Well, let me ask our colleague from Agilent here. When I first started in this field, a mass spectrometer was a large, complicated instrument that very smart people in the university laboratory used. You certainly would not give it to a 19-year-old soldier from the Army. Yes. Things have come a long way. How can you comment on the user-friendliness and the training requirements for mass spectrometry?
That's the paradox, as the instrument became more and more complex to use. But as I told you, we need to make software that are very easy to use. So it's really difficult for the user to understand where is the limit of the method, because it seems really simple to analyze using the software, but the human opinion is always the more important. And that's really difficult to train the customer to understand that, yes, the software is helping you with specific software, specific algorithm to limit the false positive and false negative, but you can't just look at what said your software. You must check every result and review all the results, all the positive, and if you have time, also the negative, because the instrument can't do everything. Yes. And that's really the complexity of the system, is to make very easy to use complex instrument, but also to make them understand that they must review the instrument very, very closely and the results.
And from Smith's Detection standpoint, I do agree with you that applying multiple different types of technology to the same detection problem really does a lot to reduce false alarms and false positives and false negatives. But does this run the risk of increasing the training requirement if somebody has to use an FTIR and a Raman device, if somebody is using explosive trace detection and X-ray detection for the explosives? How do you manage this?
Yes, first the training is very important for us, and to be sure that the guys are using the tools we produce in the field correctly. You know, the people in charge of security or in charge of the result of a detection have a lot of pressure. They have to be confident with the tools they use. They have to be confident with themselves when they spoke about the risk with the guys of hierarchy, for example, or the boss of the team, to explain what's happened and what is the procedure to correct or to protect the fields. You could produce the best technology if the guys couldn't use hazily, or if the guy couldn't use with confidence. He will stay on the storage. He will not use your devices. So for us, it's a very important point to be sure that the tools are using in the field. For sure, we doesn't cover everything, we know that. And you know, you have several companies furnishing several technology and products, and we have all a good reason to exist in the field. But main point is, if we give confidence to the end users, the guy will be clear with himself in front of the risk and in front of the bosses, of the authorities, of the people that are in charge of the protection. It's very important for us.
Well, how about the radiological perspective?
No, okay. So, as I was saying before, the question is training is rather seen in terms of developing the right CONOPS, because it's essential. Otherwise, you can have the best technology and it won't be useful because not directly connected to the operational needs. And for that purpose, we are working with the authorities, especially French authorities, in order to implement experimentally some new technologies, new detection technologies, and by trying the first responders or the security officers in the field in a non-expert mode, giving elements, some elements like dedicated software in expert modes, especially to have, for example, the decision to make a secondary inspection with another portable gamma spectrometer, for example. And as I was saying, the last step of the CONOP is to send automatically the gamma spectra when there is a real alarm, in order to get in real time in a Ridgeback Expertise Center the evaluation by an expert of the gamma spectrum with dedicated softwares, and give in real time elements in terms of decision of intervention or non-intervention. Okay. So it's an example of how we are developing dedicated CONOPS for radiation nuclear detection technologies.
Okay. I also want to address the issue of total life cycle cost. This is an important thing, not just for the end user, but for the middle management as well. Somebody has to pay for the equipment. And as we all know, the cost of the device is never the total cost of owning it. There are things like consumables, there's hydrogen gas, there are sieve packs, there are carrier gases, there is periodic calibration, there are numerous consumables and periodic maintenance and calibration expenses contained within the total cost of owning one of these systems, regardless of which type of system we're talking about. What are you doing to make it easier for the user to own the equipment? Because of course, if something has to be sent to a laboratory every 3 months for calibration, no user wants it, nobody likes it, because they only have it half of the time. And that's of course not the case really with any of the major equipment now. But I'd be curious to see what you're doing to make the operations and maintenance and the total cost of owning the equipment better. Let me start with the mass spectrometry, because again, 20 years ago, it had a bad reputation. It's something that always had to get fixed, and they would just completely eat the carrier gas, which was never cheap.
For sure, helium is not cheap at all.
No, exactly. So
that's a major problem. Major concern, yes.
What have you done to make the cost of ownership easier?
The first thing is to have instruments really easy to use in terms of maintenance. You must reduce the number of human operation in terms of maintenance, and you must have really stable instrument to avoid any calibration to make calibration too many times. Then, of course, you will play on the consumption, electrical consumption, gas consumption. But unfortunately, in my opinion, it's not really a major point when people buy a system. They only look at the price at the moment they bought, and the productivity, but just in terms of human time. But not really, they don't really focus on the profitability at the long term concerning the energy, saving helium, for an example, electricity consumption. This is not really a major concern when they bought an instrument, unfortunately.
Okay. Well,
our policy is to leave our customer to do it. So we give our customers possibility to have calibration benches, to be able to do the calibrations themselves, and a minimum of repairs that they can do themselves.
Okay.
And you are mentioning hydrogen. We have just developed a little system that we are showing here at Milipol to make hydrogen out of water by electrolysis, and we have a system to put our cylinders of hydrogen into, and you can refill your cylinders yourself on your desk. That's to make it easy. But I think everybody has the same problem to make all those things easy and cheap as possible by the user.
Nice.
In the same way, to Agilent, we developed a system to reduce the helium consumption. So to avoid the cost of helium, which is very, very high to know. But this system has only been taken consideration by the customer when we had the problem for helium delivery, not because of the cost, but because of the delivery.
Okay. I think in interest of speed here, because we only have a few minutes left, I want to talk about the overall market situation. None of us would say right now that the detection market is as good as it has been at various points in the past. Again, I've been in various pits of this business for 22 years now. I've seen the pendulum swing backwards and forwards at least 6 times in my own career, and I'm sure you've experienced the same situations. Where do you see the overall market going? Who's spending money, who isn't? What are the market trends? So I'm going to specifically ask Smiths Detection, because I know you're the largest market share in this business if you look at all the various segments. How do you see the market?
In general, the protection and security is a huge demanding in a market for critical infrastructure, for military, for fire brigades, for airports, and we receive a lot of inquiries concerning several risks or several technology to cover the risks. This is the main point. But to be honest, you have different places in the world. Europe have no money, or almost no money. Some other place in the world has more or less money, and it depends in fact of the risks. They measure the risk and they measure the budget they have to spend to protect people or not, or to protect the guys they are in the fields. So our position today is we believe the market is strong. We believe the end user asking more and more solutions in general. Our job is to give the devices or the units available for the budget, and we are trying to develop some solution like hire material, not only sell or install, but also hire with several partners in the fields.
All right. I believe that's all the time we have. Thank you very much for participating in this discussion. I wish all of you a productive experience here at Milipol, and thank you very much for joining us for this roundtable discussion. Thank you very much. Thank you.